what do we got today?
So today we got a couple of quizzes.
Okay.
So there's sort of a time constraint, but we've been doing them pretty quick, so I'm not too worried about it.
Okay. Is it stuff you can verbalize?
I believe so. I won't really be able to tell until I open it, unfortunately.
Yeah, I tell you what, verbalize everything you can, and if there are some problems that you can't verbalize, I can easily make you the presenter, so that
Okay.
at least I can see the graph or whatever it is the problem is based on.
All right. Well, we'll tackle that when we come to it.
All right. So yeah, let's do the ones we can verbalize. Okay.
So this is asking about a corresponding point. So the point negative 14, 3 is on the graph of y equals f of x. Find the corresponding point of y equals g of x, where g of x equals f of negative x.
All right. So negative x for the only point that we know of is what?
The y-intercept?
No, it's minus 14 is the one of the x points that is on this graph. Whatever that graph looks like. Let's say it's a straight line. Okay, here, let me put that point on there. Minus 4, 3. So there's minus 14, 3. We'll say that's on a straight line like that. And now they're saying that what's the corresponding point of f of minus x? Well, f of minus x, the corresponding point is going to be right there. In other words, if we, let's see, f of minus x is either symmetrical with the y-axis or the origin. So I'm guessing it's plus 14. Go ahead and see if that's right.
It's a quiz, so it won't let me. It's you one shot.
Oh, it's a quiz.
Yeah.
Yeah, let's go with 14.
Oh man. All right. So this we're gonna have to trade screens for.
Okay. Should we? We can try that right now. Let's just try it. Let me make you the presenter. Hold on. Stop sharing my screen and start using Russ. Hold on a second. Yeah. So don't feel like I'm looking at your screen. Here, let me minimize some stuff. Maybe I've got it covered up.
Oh, it won't let me.
Won't let you be the presenter?
No, the screen option won't even. So there's a record button, a mic button, a camera button, a screen, and a leave. And the screen button isn't even lit up. Like, I can turn my camera on, but I can't turn my screen on.
Yeah, hold on 1 second here. Let me see what my options here are. Let's share. I don't want that. Click on you. More options. No, hold on. They've changed this recently. I used to know how to do this real easily. Was to make the other person the presenter. Hold on. It's not under chat. Maybe it's under people. Yeah. Here I think I'm going to be able to do this. Yes. Make presenter. Okay.
Oh, there we go.
Yeah, now you should be able to share your screen. Close out people. And do you have to do anything to, I'm still not seeing your screen.
Yeah, but it says it won't, once again, it won't let me. It says
Really?
show entire screen, and then there's a share button that, once again, is not lit up.
Is that right? Well. It's unfortunate. Let's see, what are we going to be able to do here? Well, let me go back and let's certainly do all the problems that we can verbalize.
Okay.
You don't have to do them in order, do you?
No.
Okay. Yeah, let's just do all of them that we can verbalize, and then we'll deal with the other problem however we can. All right.
All right. So for the next problem, it's for the given functions, find the f of g of x and the g of f of x in the domain.
Okay.
So for the first, it's f of x equals x squared plus 3 and g of x is root 5 minus x.
Like that?
Yep, just like that.
Then the radical sign?
Yep.
Okay. So
then it's the f of g of x.
Okay, before we go there, let's figure out the domains of each of these functions. Because remember, regardless of what we get for the domain of the composite functions, we're always restricted to the domain of the individual ones. So it's the domain of f of x. Anything that x can't be?
It's the square root of -3.
No, that would just make f of x 0.
Oh, so there isn't anything that x
so
could
it's
be.
all reals. Okay. Now let's take the domain of g. How do you solve this?
Set it equal to 0.
Set it greater than or equal to 0. Very specific. And now solve that for x.
So x equals 5, or is greater than or equal to 5.
What is
it? X is greater than or equal.
Do it your way. 5 is greater than or equal to x, right?
Yeah.
Which means what? in interval notation?
It's from 5 to positive infinity.
No. That's why I don't like this method. It's confusing. X has to be less than or equal to 5, right? That's what that says. Read it from right to left. If we're not going to write it from right to left, let's read it from right to left. X less than or equal to 5. So what's the domain of X?
From negative infinity to 5.
There you go. And I got my thing backwards. This should be a bracket. And that should be a parenthesis. Okay, so now let's go over what is f of g of x going to be? F of what?
So it'd be 5 minus x, radical 5 minus x squared.
Okay, first of all, let's write it like that. That's a very important step. In other words, what you're going to do is you're going to figure out what f of radical 5 minus x is. Okay, so it's radical 5 minus x squared plus 3. Simplify that. What's radical 5 minus x squared?
It's just 5 minus x.
Okay, so it's 5 minus x plus 3. Simplify that.
So x equals positive 2.
Hold on. We're not solving this. There is no 0 on the other side. What there is on the other side is this. So simplify that for beginners. You can add the 5 and the 3 together. Russell?
So it's root 5x minus...
No, just simplify what I have circled in the middle of the page. What have I circled there? 5 minus x plus 3. Simplify that.
It's 8.
8 minus x.
Mm-hmm.
Okay. That's what fog of x is. In other words, this very first one in the upper left, that's what that is. So you can put that answer in for f of g of x.
Okay.
Okay. And notice that that has no domain restrictions. X can be anything. But we're still going to be limited by this domain restriction of g of x. So what's the next question on your test? Is it gof of x or is it the domain of fog?
Well, the next question is the gof of x, but the domain of fog is a question. So the domain of fog is still limited, so it would be negative 8 to 5.
Yes.
Or negative infinity to 5, I apologize.
Yeah, sorry, I read that as an 8 also.
Yeah.
Negative infinity to 5. So that's going to be the domain of fog. Okay. Now, let me erase just enough here that I have enough room to write. Let's talk about gof. In other words, g of f of x. So tell me what to write exactly, everything.
So it's radical sign 5 minus...
something.
Say that again?
In other words, this is what we're attempting to solve, right?
Mm-hmm.
Okay, so let's write it. G of what? This is the step that you tend to want to skip over. What's f of x?
X squared plus 3.
So it's g of x squared plus 3. That's what we're doing. Now substitute it.
So it's root 5 minus x squared plus 3.
in parentheses, all of it. And if you don't use the parentheses, you're getting the wrong answer. Okay? Because what the parentheses does now is this minus sign applies not only to the x squared, but also to the 3. So simplify that. Remove the inside parentheses and then simplify. Remove those parentheses and tell me what you have.
So it's x to the...
Hold on. Remove the parentheses. You still got the 5. Or I shouldn't have written that. You tell me, what's the rest of it? You're simplifying that right there.
I'm lost.
Okay, over here on the far left, what I've circled, I want you to simplify it. I want you to simplify it by removing the parentheses. How do you remove the parentheses? What is left after you remove the parentheses? Still
X
have the 5.
It's x squared minus 8.
Give me everything. 5 what?
5 minus x squared plus 3.
Minus 3. This negative sign has to be applied to that number. That's why it is so important to use parentheses in the first place. You with me?
Yeah.
Okay, now simplify the bottom left line.
So it's 2 minus x squared.
Okay, so that's what goes inside here. It's 2 minus x squared. So all we had to do is get rid of the parentheses that were inside. So that is g of x squared plus 3. And that's actually g of f of x, goff, also. And that's the answer you want to put in. Can't be simplified.
Okay.
Now, let's figure out what the domain of goff is. How do I figure out the domain?
Well, it's off of the two parent functions, and then you set g of f of x equals 0.
No, just look at this final thing in the middle. That's goff. They want the domain of that. Forget everything else for the moment. Just look at square root of 2 minus x squared. What's the domain of that? How do I do it?
Set it equal to 0.
What did I do up here?
You set it greater than or equal to 0.
Okay, that's different. Okay, a lot different. It's not an equation. It's an inequality. And the reason it's a lot different is because this is not going to be that easy to solve. You're going to end up with what? 2 is greater than or equal to x squared. And whenever you're taking the square root of both sides in an inequality, you have to, well, if we just take the square root of both sides for starters, then that has to be less than the square root of 2. But it also can be greater than the negative square root of 2. So actually the domain is between the negative square root of 2 and the square root of 2. And let's think about that for a moment. Could x be minus 3?
No.
Okay. Can x be minus square root of 2? I'm looking up here now. Okay. Yeah, because that would be 2 minus 2, 0. And x can be all of those little numbers between negative square root of 2 and positive square root of 2. It can be 0, it can be 1, it can be 1.4. It just can't be less than negative root 2, and it can't be greater than root 2. So we have that domain for Goff. And now let's see if this domain is more restrictive than that domain up there on the upper right. Well, it certainly is on the left. We're not any longer allowed to go to negative infinity. And we're not going up to 5. So this is the most restrictive domain for Goff. And that's the one you want to put in.
And they have brackets because it includes root negative 2.
Because it's greater than or equal. In other words, this equal sign goes with brackets. If it's just greater than or less than, then it's parentheses. I have a way we're going to solve our other problem. You can go back to the ones we're skipping.
Yeah.
Okay. What we're going to do is we're going to do all the ones we can do verbally. And then I want you to put on the page the ones that you can't do verbally. And I want you to take a picture with your camera and email it or send it to I'd rather you send it to my email address. You could send it to my camera and I'd be able to see the problem and we could go from there. So that would work also. But it might be a type problem where I'd want to write on it and stuff, and that'd be better off if you sent it to my email. It'd be faster for you to send it to my phone. But that's the way we can deal with those. All right, what else do you have that you can verbalize?
Determine the symmetries of the graph of the given relation. So xy equals 6.
Okay. That is the standard format for a hyperbolic function. Here's the parent function. What that looks like is that. Okay?
Mm-hmm.
Now, the 6 is the same as putting a 6 out in front of the function, so it's a vertical shift, which means everything goes up vertically by 6 units. Wow. Now it's going to be something that looks like this. And there's no symmetry on that. The parent function has symmetry about the origin. This function that we just graphed, which is 6 over x, does not have symmetry about anything. It does have symmetry about that line. But it's not asking about that, is it?
No.
So is none a solution?
Yeah, it is not symmetric.
Okay, there you go.
Okay.
There are the 3 possibilities, the y-axis, the origin, and none?
There's 4. It has the x-axis as well.
Okay.
So.
Yeah, you got to be a little careful. It doesn't take much to take away the symmetry. In other words, a little shift is all it takes.
So this one's about transformations.
Okay.
It's just describe how the graph of g of x, which is 1 over x plus 6, and then that whole thing is subtracted by 3.
Okay.
Yep, just like that. So describe how the graph g of x can be obtained from the graph of f of x, which is 1 over x.
So let's take a look at that right there. Let's just work our way left to right and figure out whether we're looking at a horizontal or a vertical shift, or stretch or shrink.
So it's inside. So it's horizontal.
Okay, good, because it's inside the function.
It's a shift because it's positive, and it goes left 6.
Good. Shift left 6, okay, and then what about that?
And that would be horizontal, so it would be...
Hold on. Is that inside or outside the function?
It's outside, so it's a vertical shift down of 3.
There you go.
Oh, 3, okay. So this is another f of g of x problem.
Okay.
So given that f of x equals 3x plus 5, and g of x equals x squared minus 3x minus 5, find g of f equals 7.
The way we want to pronounce this is g of f of 7, right? Is that the way they're writing it? In other words,
yeah.
It's g of, the parentheses mean of, f, and then another set of parentheses, so it's g of f of 7. So where do we start?
So you plug in g of x for f of x.
Always start inside out. What's f of 7? That's easy.
So you plug 7 in for x in the f function.
So what's f of 7?
It's 28.
26. 21 plus 5. So
I have it written down.
They're really saying, what is g of 26? So that's what?
Oh man, I can't. 3 times 26 in my head.
Well, just write it. Don't give me an answer. Just tell me what I'm going to do.
So it's 26 squared minus 3 times 26 minus 5.
That's always what you want to do, no matter your level of math ability. If you want to avoid making mistakes, it's always best to fill it in and then go from there. So 26 squared is 676 minus 78 minus 5. So that is 598 minus 5 is 593. That is g of f of 7.
All right, so the next one is find f of x and g of x such that h of x equals the f of g of x.
And these are always the hardest ones. What other information do they give us?
H of x equals x to the sixth minus 8 over x to the sixth plus 8.
Okay, so these take a little bit of trial and error. And I'm not sure I know how to teach that. Let's see. We want what's on the inside to be x. Hold on a second.
It is a multiple choice. So if we just find x or f of x, then it would all the f of x's are different.
Okay. What are they asking for a multiple choice answer? Is it the f of x?
Well, yeah. Choose the correct answer below, and then there's f of x equals x to the sixth. G of x equals x minus 8, x plus 8.
Hold on.
And then the next.
Hold on. X minus 8 over x plus 8.
Yep.
Okay, that's about as far as we need to go. No, it isn't. Keep going.
So then B would be f of x equals 1 over x to the sixth plus 8. And then g of x equals x to the sixth minus 8.
Let's see if that one works. So f of x to the sixth minus 8 is not going to work because I'm going to plug it in and I'm going to get x to the 36th. Okay? What are your other two answers?
C is f of x equals x to the sixth minus x over x to the sixth
over
plus
or
x.
g of x is different?
No, so you got f of x is x to the sixth minus x over x to the sixth plus x.
That's got promise. And g of x is just x, right?
8. Well, it'd be 8.
Okay, so if g of x is 8, then fog is f of 8 which would be 8 to the 6th minus 8 over 8 to the 6th plus 8. What's the final answer?
F of x equals x minus 8 over x plus 8. And then g of x is x to the sixth.
All right, this is going to be our answer. In other words, what is this right here? If the bottom one is our answer, then what is it? It's f of what?
F of x minus 8.
F, hold on, it's f of g of x. So start with g of x. What's g of x?
X to the sixth.
Okay, so we want to figure out what f of x to the sixth is. If this were indeed f of x, then f of x to the sixth gives us h of x. So your answer is D. And yeah, these are pretty hard to unscramble from start. I might have come up with that with a few trial and errors. Yeah, it wouldn't have been that hard. Yeah, okay. Probably could have done it directly without having to check all 4 multiple choices.
So the next one is a symmetry problem.
Okay.
So
is it showing you a graph or is it giving you a function?
It's giving me a function, so it just says determine the symmetries of the graph of the given relation, but it's just the equation. So it's 2y equals 3x squared minus 5.
Okay. So y equals that, and that equals f of x. And we know that if we had y equal x squared, it would look like that, right?
Mm-hmm.
That is y equal x squared. So the 3/2 that is in front of the x squared, what is that going to do?
That's a shrink?
Stretch.
Stretch.
Yeah. When you're talking vertical stretches, remember that numbers greater than 1 are stretches. They're not shrinks. Numbers between 0 and 1 are shrinks.
Okay.
So a stretch would make it look like this, right? Make it skinnier.
Mm-hmm.
Now what's the minus 5/2 do?
It moves it to the left.
Inside or outside the function?
Also, it moves it up by 5/2.
The negative sign in front of it.
Moves it down by 5/2.
Okay. So goes down to something like that. What kind of symmetry does that last line have?
None.
Symmetrical with the y-axis.
Oh, okay.
See why?
Yeah.
That distance, same as that distance, same as that distance, all the way down. That distance, same as that distance. If you took the left half of that parabola and reflected it about the y-axis, it would land on that line right there. So you can see that the vertical shifts do not mess with the horizontal symmetry, nor do the vertical stretches or shrinks. You still maintain the symmetry. If I were to move this, if I had something like y equal x minus 2 squared, well, now that's no longer a parabola. That's a parabola over here, and that doesn't have any symmetry at all. So when you have horizontal shifts, you mess with the y-axis symmetry. You're not going to have a lot of functions, at least, that are symmetric with the x-axis, so we don't even need to talk about those. But okay, what else?
So this one, I feel like this one might be. This will answer a couple of questions I have if we could do this one here.
Okay.
So it's a graph, and it just goes from 2 to -2, both on the x and y axis. And then it's just an upside down U shape from -1 on the x-axis to +1 on the x-axis, and it goes to +1 on the y-axis. So it's just a simple U shape, upside down U.
Like that?
Yeah, but it stops at the x-axis, yes.
It stops.
Yeah.
So it's not a parabola, it's just a piece of a parabola?
It's just a half circle across.
Is it a parabola or is it a half circle?
It's just a half circle. It does not cross the x-axis.
Okay.
And it's all it's asking is the function odd, even, or neither?
Okay. Even functions are symmetric with which axis? And the way you can remember it is remember this function right there that has an even exponent. What axis is that function symmetrical with?
The y-axis.
Okay, so even means y-axis symmetry. Odd means what kind of symmetry?
Against the x-axis.
No. Odd means symmetry with the origin. Totally different. And you don't really have functions that are symmetrical with the x-axis, because as we talked about the other day, they wouldn't be functions. So
Yeah.
what is that symmetrical with?
The y-axis.
So therefore it's even.
Even.
And
okay.
that function, here's the equation of that circle. Just so you know. Right? If
Okay.
it were a whole circle, in other words, if I were to draw the rest of the circle, that would be its equation, what I've written right there. But it wouldn't be a function. And if I solve this equation of the circle, I get y equals plus or minus square root of 1 minus x squared. What you are looking at in that red half of a circle is the plus side of that function. The minus side is the bottom half of that circle that isn't there. It doesn't exist. So that's the equation of that figure that you have right there. Not that they asked for that. You don't need it, but I thought it was worth pointing out. That when you have
then if I have
a circle and you solve for y, the plus is the upper half, the minus is the lower half of the circle.
Okay. So, and then if I had a line that was symmetric to the x-axis, it would be neither even nor odd.
I can't correct. The only thing I can think of would be something like that, a horizontal parabola.
Okay.
The equation of that is actually x equal y squared instead of y equal x squared. But that is not a function. Excuse me, that should go all the way over to that. And yet that is symmetrical with the x-axis. I'm trying to think of functions that might be symmetrical with the x-axis. Yeah, I can think of one. No, I can't.
So I'm looking at one that's so I guess that wouldn't be right. Okay, no, keep going. Sorry.
Well, I was sitting there thinking, if I drew a straight line like that, is that symmetrical with, you tell me, what's the symmetry on that line?
See, I would say it would be the origin.
Yes, it is. And that's y equal x. Okay, so that's f of x equals x. So what is f of minus x equal? Well, it equals minus x, which happens to equal minus f of x. So if f of minus x is equal to minus f of x, it's odd, and it has symmetry about the origin. Remember that test. The test for odd or even, you figure out what f of minus x is.
Okay.
All right.
All right.
Let's go back to this color. I like this color better. What really helps on these translated functions is to know the parent function, know how to graph the parent function, and know how to graph the translated function. Once you do all of that, you'll be able to see the symmetry by just looking at it, or the symmetry or lack of symmetry by looking at
it. All right, so for this one here is find the fog and goff of x. So for f of x, it's 4 over 1 minus 9x.
Okay.
And for g of x, it's 1 over x.
Okay. First question is fog.
Yep.
It's the first thing I should write. And let me make it a little simpler. That's what fog means. F of g of x without the O. There. So that gives you your starting point. F of what?
4 over 1
Hold on.
minus
Make
9.
sure you get your right functions. You don't want to mix the functions up. It's g of x that goes inside the parentheses. Right?
Yeah.
Okay, what's g of x?
1 over x.
Okay, so that's what we're trying to do. Now, what is that equal to?
4 over 1 minus 9 times 1 over x.
Just like that, right?
Mm-hmm.
You have to simplify this. And in order to simplify it, we can't copy dot flip yet because we have two terms in the denominator. So we have to combine those two terms into one term. So over here, let's figure out what minus, how we solve that problem. How did we turn that into one rational quotient? What's common denominator?
1 minus 9 over x.
What's the common denominator between these two things that we must subtract?
1.
X does not go into 1. So no, that doesn't work. 1 goes into x, and x goes into x, so x must be the common denominator. What goes in the top left numerator?
The 1.
I'm converting 1 into something that has x as a denominator. What must the numerator be?
X.
Okay, that's what is equal to 1, not 1 over x. It's got to be, when you do these, you always have to do it so nothing changes. In other words, this always has to be equal to that, and this always has to be equal to that. Okay, now combine them. What do you get? What's x over x minus 9 over x?
9 minus x.
Do the numerators first and leave the denominator the same when you're doing addition or subtraction of fractions.
So x minus 9.
Okay. Now that is a single rational quotient. And that's the same thing that's inside here. So I'm going to replace it with x minus 9 over x. And now we can copy dot flip. So what is this after I copy dot flip it? If you're having trouble with these, spell it out. 4 times what? In other words, we're turning it into a multiplication problem. So instead of this division sign, it's going to be multiplying for sure because we're copy dot flipping. Now flip.
So it's x over x minus 9.
Okay, and now combine, and the 4 goes with the numerator, so you end up with 4x over x minus 9. There's your answer. Okay, and do we need domain on this or anything?
Yes, we do.
Okay, so what's the domain restriction on the fog of x?
It has to be greater than 9, negative 9.
No, there's no radical sign here, so it's not a question of positive or negative. It's a question of we can't divide by 0.
So it can't be a positive 9.
Okay, so x cannot be 9, and it's equal to all reals. Now, let's go back and check the domain of both f and g of x. Well, g of x is all real, except what?
Zero, except for 0.
And f of x is all reals, except for what? What makes the denominator 0? Write it out if you need to. Go 1 minus 9x equals 0 in this case, because we're trying to figure out what value of x would make that denominator 0.
So negative 1/9?
1/9. Okay? So we have a restriction in the f function that x cannot be 1/9. We have a restriction in the g function that x cannot be 0. And we have a restriction in the composite function that x can't be 9. So the domain of the final function, start from negative infinity, go to what?
To 1/9?
Let's go to the smallest number first. We got 3 numbers we're dealing with: 1/9, 0, and 9. What's the smallest number?
Negative infinity to 0.
Okay, and it can't be 0, so in conjunction with what?
0 to 1/9.
Good. In conjunction with, or in union with?
9 to infinity.
Well, no, we got to cover all numbers except these 3 numbers, which means I got to pick up with 1/9 always. In other words, this number is always going to be equal to that number. That number is always going to be equal to that number to 9, right?
Mm-hmm.
And union with 9 to infinity. So there's 4 intervals in that domain restriction.
So that's it's a multiple. The domain of fog is a multiple choice, and that's not one of the options.
Really?
Mm-mm.
What are the options?
Negative infinity to negative 9, union negative 9 to 0, union 0 to 8. Another one is...
Whoa. 8? Where are they getting an 8 from?
Oh, I'm sorry. Yeah, I'm sorry. I said 8 instead of infinity. So it's negative infinity to negative 9, union negative 9 to 0, union 0 to infinity.
Negative 9 to 0? Where are they getting negative 9? Did I mix my sign up here accidentally? Let's see. I had 1 minus 9 over x, which is x minus 9 over x. Copy dot flip. Still says x minus 9, so 9 it can't be. Not negative 9. So take your negative 9 answers and cross those out. Those aren't right.
Okay.
I could conceivably believe that it might be this. Because that would be the domain of the fog function, without the domain restrictions of the f function or the g function. My understanding of it may not be correct. My understanding was that you're always restricted by all 3 domains. But if this is one of your choices, that would be the domain of the fog function only.
And that is one of the choices.
Yeah, what are the other 2 choices?
Negative infinity to 0 with a union at 0 to infinity.
Okay, that would be including the g of x restriction.
And then the last one is negative infinity to 0, union 0 to 9, union 9 to infinity.
Sounded like the same as the previous one. Do those two differ?
Yeah, they do in the sense that 0 to 9 would be the middle union.
Okay, so you got negative infinity to 0, and then 0 to 9, and then 9 to infinity.
Yep.
Why are they not including that restriction right there of 1/9? Did I make a mistake there? No. 1 minus 9 times 1/9 is 0. So they're acting like the g function might restrict it, but not the f function. I honestly don't know what they're doing here. And I guess, if I had to guess, oh man, I know those original functions affect it. Maybe it's just the inside. Maybe it's just the g of x function that affects it. In which case it would go from negative infinity to 0, and then from 0 to 9, and then from 9 to infinity. If the only restrictions are the final function and the g function. And I suppose that that could be correct. In other words, the g function is the inside function. I don't know. I guess we're going to have to go with that answer or the answer that went from negative infinity to 9. In other words, don't let either the f or the g function restrict it. But I'm almost certain that that is not the case. So I guess if I had to bet money on this and pick something, I would go from negative infinity to 0, 0 to 9, 9 to infinity. That doesn't really make sense to me either, but I don't know. I would suggest, we'll find out at the end because it'll tell us.
All right, well,
the question is, what is the domain of the fog function?
That is the...
Specifically, tell me how it's worded.
What is the domain of fog? So I think negative infinity to 9 is going to be...
I think so too. Let's go with that one. Let's ignore the two domain restrictions of the f function and the g function. We're going to get the answer to those coming right up, I imagine. Maybe not.
Yeah, so the next question is the g of f of x.
Which is, yeah, not the same. In other words, now we have to do the same thing. Here, let me just, I can erase all of it easier. F of x was what?
4 over 1 minus 9x.
And g of x?
Is 1 over x.
Okay, so start me off. We want gof. And gof means this. So, next step.
So it'd be 4 over 1 minus 9
Read
times 1.
Starting what? What does that mean right there? G of f of x. That's what we have to start from.
Okay.
Don't forget the first step, which you don't like doing, but it's critical. The first step is to fill in what f of x is. Right? There's f of x. Instead, that doesn't do us any good looking at f of x, but if I can put a function in there, now we'll know how to proceed. What's the function that goes in there?
1 over x.
That's the g of x function. We want the f of x function.
So it's 4 over 1 minus 9x.
Okay, this first step, I want you to always do that first step. Don't ignore that. Now it's relatively easy to go from there. So what is that equal to?
4 over 1 minus 9
No,
times
1
x.
over x, and we're going to substitute what's inside the parentheses wherever we see x in the g function. In other words, here's what's inside the parentheses. You're going to substitute that for x in the g function. So what's that equal to?
1 over 4 over 1 minus 9x.
Okay. Now the question is, can we copy dot flip that? Not sure, but to be safe, we won't. In other words, I'll do it the same way I did it before. This down here is x minus 9 over... No, it isn't. Excuse me. I can copy dot flip that because we don't have a dual term in the denominator. Our denominator is actually a single rational quotient like that. So we can copy dot flip it. What do you get? Do you have
1 over...
a pencil and paper? You really kind of need one in these sessions in front of you.
Yeah.
So you can actually do that, Matt.
So it 1 over 4.
Copy dot flip means this. I'm going to take the numerator and I'm going to multiply it whatever the reciprocal of the denominator is, which is 1 minus 9x over 4, correct?
Yes.
That's what you do when you copy dot flip it. Well, we don't need the 1, so that's our answer. Now, question of domain. If we go with the same strategy that we went with before, then there are no restrictions to that x. But the g function x can't be 0, and the f function x can't be 1/9. Maybe we can, you've already answered the other one, huh? So we can't change that. I was going to say, if we can figure out the answer to this one, we may figure out the proper strategy for the previous one. What kind of options do they give you for the domain of Goff?
So every
there one that's all real numbers?
No.
Really?
Yeah.
There's no negative infinity to infinity?
Nope.
Okay, so that means that they are using the restriction of the underlying functions, which means we didn't get the last one right. The problem is the last one, they did not use the restrictions of both of the underlying functions. They used the restrictions only of one of them, the 0. So let's say, I'll bet this is an answer. Lower left, all real numbers except 0. Oh, it's not 0. Well, no, it could be, because if we're taking the domain restriction of the g function only, actually, the last question, the restriction they were allowing was the 0, which was the restriction on the inside. And the restriction on the inside is actually 1/9, not 0. Is that an answer? Negative infinity to 1/9 in union with 1/9 to infinity?
Yeah,
That's
that is an
it.
answer.
That's it. And the previous question's going to include the 0 and the 9 as numbers that x can't be. So, by my new understanding of this now, you don't take the restrictions of both functions. You take the restrictions of that function only.
Okay.
And the final function. In other words, that has no restrictions, so we're not worried about the Goff restrictions. But the restrictions on the f of x function, x cannot be 1/9. Just like the last time when we had f of g of x, remember g of x was 1 over x, and that restriction was it couldn't be 0. Nowhere did they mention the 1/9. So they didn't care about the restrictions on the first part of the composite. They only care about restrictions on what's inside the parentheses and the restrictions of the final function.
Okay.
So let's go with that.
I think this is a transformation question.
Okay.
So it just says, describe how the graph of the following function can be obtained from one of the basic graphs.
Okay.
So the equation is h of x equals 6 over x.
And they just want how that is a transformation of the basic elementary function?
Yeah, well, it's kind of weird. It's got like 4 boxes. So it says to obtain the graph of h of x equals 6 over x, start with the graph of y equals blank.
Okay, what's the parent function?
1 over x.
That's what they're talking about.
Oh, okay.
And then all this is being multiplied outside the function by the number 6. It makes it a vertical stretch.
All right, so to obtain the graph of h of x equals 6 over x, start with the graph of y equals 1 over x, stretch it vertically by multiplying each x coordinate by 6, or is it y coordinate?
It's a y coordinate.
Each y coordinate by 6, okay.
In other words, here, let me give you an explanation of that using an easier function. That's y equal x squared, right?
Yes.
In blue, I draw this one. That is y equal 2x squared. So you have a vertical stretch factor, right? And the way you can always figure these out is what's being stretched. It's the y coordinate that's doubling. If I look at that y coordinate and I look at that y coordinate, the y coordinate is always 2 times whatever the original was. Whatever the original point is, the new point is twice as far away from the x-axis, which means the y point has been stretched 6 times.
Okay.
Now with a hyperbola, your basic hyperbola is this. This is the 1 over x. And so if I'm going to multiply this by 6 to come up with a blue, then this point that's right there on my original function has to be 6 times further away. Same thing for all of them, and what it ends up doing is flattening it tremendously.
All right, so this is the last question before we'll probably go back. So it's decide whether f is even, odd, or neither.
Okay.
So f of x equals x to the fourth.
What's the test?
Minus,
determine that. Oh, go ahead.
Minus 4x squared plus 6.
Okay. There's a quick and dirty method of doing this. If all of your x exponents are even, then it's an even function. First of all, tell me what the test is for determining it. What do I have to check?
Multiply it by f of negative.
Of what? F of negative x.
Yeah.
That's not multiplication. That's determining what f of negative x is going to be. Well, if I substitute negative x and make sure I use parentheses, I get this. And notice that all of the negative x's become positive.
Mm-hmm.
So I get the same thing I started with. That is x squared. So it's still minus 4x squared plus 6. So f of x, or excuse me, f of minus x is equal to f of x. What's that make it?
This makes it even.
Yeah. If one of these was like cubed, would be neither.
Okay.
Or if it's just x, if I just made that 4x, you're going to end up with something that is neither f of x nor is it minus f of x. Remember, here's what you're looking for is either that or this. Anything else is neither. If it's f of x, it's even. If it's minus f of x, it's odd.
Okay.
Anything else is neither.
All right. So for this question, it's another transformation question. So it's describe how the given function can be obtained from one of the basic graphs. So g of x equals x plus 4. And that whole thing is squared, so it's parentheses x plus 4 parentheses squared. There you go. And then minus 2 outside of the function. There you go.
Okay.
So then it's to start with the graph. So start with the graph of x squared.
That's the parent function. Now let's just examine this function, everything that it is different than x squared. So the first thing we find that's different is there's a plus 4. So the plus 4 does what? Horizontal or vertical?
Vertical shift. Horizontal shift up.
Inside the function is horizontal, outside is vertical. That plus 4 is inside the parentheses. So it's inside the function. So it's horizontal. Which way?
Left 4?
Yep. Okay, that takes care of that whole part. And the only thing else we have is the minus 2. What is the minus 2 doing?
It's a vertical shift down 2.
There you go.
All right. And then it says, I wonder, is it going to make me graph this? Oh, it is. Okay. So.
Okay, so start with your parabola. The vertex of the parabola is going to be shifted left by 4 units and down by 2 units. So the vertex of the parabola is going to be like that. There is no stretch factor, something like that. As long as you get that point on, you're probably going to get it right. That point is at minus 4 comma minus 2.
Oh, man. It's not easy.
No, I imagine it isn't. You have to put 2 more points on there?
Well, it's if only it would let me just put some points on here. Hold on. This is going to take me a minute. Just give me a second here. Let me see if I can figure it out.
In other words, do you need the vertex or do you need 3 points?
No, I need the vertex, but it's not like I can just click a point on the graph. I have to use the slide bar.
Okay.
That's the only way I can explain it.
Well, because there's all kinds of parabolas you could put in there. You could put the parent function parabola, but you could put a stretch one also. That's not correct, even though it has the same vertex. So you got to make sure that the parabola you put in there is the standard parabola, not and the only way I can think of that you'd be able to do that is if you can put 2 other points on there.
I figured it out. It was just a hassle. The way that they did it was just not easy. I'm sorry.
Okay. No, I've seen that before. It isn't easy. Okay. Anything else on that problem?
No, that was the end of that problem, but I do have one last problem here.
Okay.
So how can the graph of g of x be obtained from the graph of f of x?
Okay.
And then it has 3 little pictures of graphs here that I'm supposed to choose from. So it's g of x is the cubed root of x, and then the outside of the root symbol is -3. Yep, just like that. And then f of x is cube root of x.
Okay.
Yeah.
They want to know how g of x can be obtained? What's the question, Reed?
Yeah. How can the graph of g of x be obtained from the graph of f of x? So it's really what transformations occur. So it's really just
it's a pretty simple one. What's going on in that one relative to the parent function?
It's a horizontal shift.
Inside or outside the function?
Outside. So it's a vertical shift down of 3.
There you go. So what that looks like is, actually, cube root is one that I have a hard time drawing. I don't know why. Cube root is a reflection across that line. So should look like this. That's the way you do it. So that, let me put it in blue. And now this is what the cube root of x looks like.
Yeah.
Now, if I'm going to shift that down 3 units, then it's going to look like this.
Okay. Looks like graph
that
B
point is shifted down to -3. That point that was 0, 0. In other words, this point really, I drew it, I didn't draw it quite right. There's the inflection point. That blue point should be right there.
Okay.
Now, why don't you go back to the one that you couldn't verbalize?
Actually, that was the one that would have been the hardest for me to verbalize because it had graphic questions, but it was really just choose the graph.
Well, an easy way to handle a problem like that is take a picture of it. Let's just try it real quick. I'll bet we can do it in 10 seconds. Take a picture of that screen.
That's the thing. We just did that problem.
So it went away?
Yeah, I just turned in the test. I only missed 2.
Okay.
It's not bad. But of course it's a quiz and it won't let me go back to them. So
can we figure out which one we missed?
no, it won't. It won't let
I
me.
know we missed one of those domain problems because we did two successive domain problems differently. So I know one was wrong.
Yeah.
I did learn something though, that when you have f of g of x, it's only the g of x restriction that carries forward. And if you have g of f of x, it's only the f of x restriction that carries forward. At least that's what I think. It's not both of them. And of course, you have whatever restriction you get on the composite function. In other words, you have that restriction, but you don't combine it with the restrictions on both f and g. You just combine it with the restriction on the inside of the parentheses function. That's the way, apparently, it works.
Well, I do have another quiz here if you want to get that one started.
Sure. Yeah, and if you do come across a problem that you can't verbalize, just take a real quick picture of it and send it to my phone. And then I'll get it on my phone within 10 seconds, and I can be looking at what you're looking at.
Okay, perfect.
We can try that and see how well that works. I may end up having you have it send it to my email, because then I can bring it up and look at it in bigger size than my phone. But I can zoom in on the phone also, so I should be able to handle it on my phone.
Okay. All right. Well, the first question in this next quiz is just says solve.
Okay.
So x to the fourth minus 11x squared plus 10 equals 0.
Okay. This looks like a quartic, but you'll notice it's actually a quadratic in disguise. What do I mean by that? Let's go over here and let's let u equal x squared. Okay?
Mm-hmm.
So now I can rewrite this quartic as u squared minus 11u plus 10 equals 0. I can factor it just like quadratic. So it's u minus 10 times u minus 1. So I can solve it. U equals 10 and u equals 1. And now let's go back over and solve for x. Well, if u equals 10, then 10 equals x squared, and x equals what?
100.
How do you solve it?
Square root of 10?
Square root of 10, not square 10. So it's not 100, it's the square root of 10. You're solving it by taking the square root of both sides. What did I leave out? Whenever you solve an equation by taking the square root of both sides, you begin your answer with what words?
Plus or minus.
So there's two solutions to this equation. And then we had another u equal 1. So let's go substitute 1 for u. Solve that for x.
Just 1.
What answer do you always start your answer with what words?
It's positive or negative.
So there's your 4 answers for this quartic. There's only, there are 4 specific answers. All 4 of them will work. If you want to go plug it in and test it, all 4 of those will work. So it's plus or minus 1, plus or minus root 10. Now, let me just suggest something. This may not be your cup of tea the way I did it over here. So let me just show you another way. You don't have to use U-Substitution, but you do have to recognize that you're looking at a quadratic. Okay? So if I'm looking at a quadratic, can't I also factor that as this way? Does that not give you exactly the same thing?
Yeah.
Okay. And now I'm going to set that equal to 0. So x squared minus 10 equals 0, x squared equals 10, x equals square plus or minus square root of 10. So I'm able to do it the same way, it's just I didn't use this U-Substitution. But you have to be able to get from there to there, which isn't always that easy if you're not used to it. So using the U-Substitution, it actually turns it into a quadratic, and then you can factor it like you would any quadratic. But if you get used to doing this kind of thing, where I go from that to that step, then you don't have to use the U-Substitution. You can just do it directly. U-Substitution is not required. It just makes it a little bit easier to understand what you're doing.
All right, so for the next one here is the diagonal of a TV set is 13 inches long. The length is 7 more than the height. Find the dimensions of the TV set.
Give me some equations.
Well, it's...
Okay, let's start with what they gave.
No.
Length is what?
We don't have 7 inches 7 inches more than height, so it's
Then it's h plus
L
7.
is 7 plus h.
There you go. Okay. And what other equation can we apply? It's a right triangle. So what do I know? I know L squared plus h squared equals 13 squared. Pythagorean theorem.
Mm-hmm.
And now I can use substitution. I can substitute h plus 7 in for L, and I'll have one function that's all h, and I can solve for h, and then I can solve for L. However, let's consider some of your simple Pythagorean right triangles. What's the smallest perfect Pythagorean right triangle? 3, 4. It's the hypotenuse of a 3, 4.
I have no idea.
You're not familiar with the 3, 4, 5 right triangle?
Not in the slightest.
That you should, because they will give you tons of these. In other words, they don't want you wasting all your time solving the Pythagorean theorem or even solving for those two equations. You should always remember these two. These are your minimum two. There are no other ones that are smaller than this. In other words, there is no such thing as a 2, 3, 4 right triangle. There's a 3, 4, 5, and then the next one is a 5, 12, 13. So the moment you hear that 13 as a hypotenuse, you should be considering, could the sides be 5 and 12?
Okay.
Can they? Would that make one side 7 inches longer than the other side?
Yeah.
Perfect. There's our answer. We don't even need to solve all that math. So all we needed to do is be familiar with your 5, 12, 13 right triangle. And those are the only two that you need to really remember. The next one is like 8, 24, 25. So the rest they don't give you. And if you were to take an SAT test tomorrow, of the right triangles that they might give you 10 right triangles, 9 of them are going to be this type. Either a 3, 4, 5 or a 5, 12, 13. Now,
Okay.
when I say that, it could be 30, 40, 50. In other words, it could be multiples of those. Or it could be 6, 8, 10. But the moment you told me the diagonal was 13, I knew it was going to be a 5, 12, 13 triangle. Which is the fast way to do it, is to recognize that, and then you realize, well, wow, yes, the width is 7 inches, or the height is 7 inches greater than the width. That's my answer. Is the length is 5 and the height, excuse me, the length is 12 and the height is 5.
Okay.
So it's really a 12, 5. Same thing, still have that triangle. It looks like this. 5, 12, 13, and your TV screen would be more rectangular that way. Rather than having, if you had a height of 12, your TV screen is going to look like this. And that's not the way TV screens look. So the length is 12, the height is 5.
Okay. So for this next question, it's expressed in terms of I.
Okay.
So it's negative root negative 16.
Okay. What's the first thing you always want to do when you have a square root sign with a negative number in it?
There's also a negative in front of the root sign. So there's a negative root sign, negative 16. There you go.
That's fine. That's not the part we care about, that first negative sign. The part that gives us difficulty is that one, because you cannot take the square root of a negative number without getting into imaginary numbers. So let's start with that, and then we'll add the other one in. What I'm trying to get at is you always take out a square root of 1 as your first step. Leaving what else?
16.
Square root 16. Okay. And that is 4, and that is I. So that would be 4i. Now, if we go back and pick up the negative sign, that just goes right there. So it's equal to minus 4i. In other words, this negative sign isn't important. It just carries through all the other process. The process that's important is breaking that up into a square root of a positive number and the square root of negative 1.
Okay. So the next one is multiply.
Okay.
And express in forms of a plus bi.
Okay. So they're telling you they want the answer in that format. Precisely. Okay, go ahead.
So 4, so it's, I get left paren 4 plus 7i, right paren, left paren 8 plus 5i.
Foil it. Foil it. Step by step, just read the first and I'll write it down, and then read the outside and I'll write it down, and the inside I'll write it down like that. What's the first?
32.
What's the outside?
20i.
What's the inside?
What is that? 42i?
56.
56. Dang it.
And what's the last one?
35i squared.
Okay, you should have a calculator. Just a little simple 4-function calculator like I have. You need one of those in front of you also. So let's simplify this. Combine those two middle terms, which always combine. 20i plus 56i.
It's 76i.
Okay. And then convert this into a real number. What's I squared?
I'm sorry, say that again?
What's I squared?
-1.
Okay, so what's plus 35 times I squared?
-35.
Now combine your real numbers, that one and that one.
It's -3.
That's the A plus BI format. A is -3, B is 76.
Okay. So the next one is I to the 32nd.
Okay.
It just says simplify.
Okay. When you have an exponent above an I, divide the exponent by 4, and whatever the remainder is, replace it with the exponent. Divide 32 by 4. What's your remainder?
8.
That's your quotient. What's the remainder?
It goes in evenly.
So it's 0. Anything to the 0 power is 1. Remember that? Here, let me just do it one more time. And then it repeats. I to the 5th is the same as I to the 6th is the same as I squared, I to the 7th is the same as I cubed. So I to the 8th, which you'll notice is evenly divisible by 4 with a 0 remainder, is the same as I to the 4th. I to the 32nd is the same as I to the 4th, which is also 1. So if you had I to the 33rd, you would divide it by 4. Your remainder would be 1. That would be equal to just I. So if I had I to the 33rd, that would be equal to I to the 1 power, basically. Every remainder is. I to the 34th would be equal to I squared. That's the remainder when you divide by 4. You're always dividing by 4 because it is periodic. Every 4 it repeats itself.
All right. So the next one here just says solve again.
Okay.
And it's x to the 1/2 minus 6x to the 4th.
6x to the 4th, okay.
Or to the 1/4.
Right.
Plus 5 equals 0.
Okay. Similar to the quartic, this is actually a quadratic in disguise. Okay. Now, I'll do it the new way without using U-Substitution. How do I break that up? If I got to split that into 2 x's, what's it going to be? In other words, if you think of this as a quadratic, let's factor it just like it's a quadratic. Only instead of x and x, it's going to be x to the 1/4 times x to the 1/4, because that multiplied by that gives you x to the 1/2. You add the exponents. With me?
Yeah.
What are both signs going to be?
Positive, negative.
And the only factors of 5 are 5 and 1. So if you were to FOIL these two back together again, you're going to get exactly what you started with. With me?
Mm-hmm.
So if all of that's equal to 0, well, then we have x to the 1/4 minus 5 equals 0. Solve that for x.
So
What's x to the 1/4 equal to?
I have no idea.
Hold on. Do this step by step. Don't try to solve the whole thing in one step. You eat an elephant one bite at a time. So what's the first thing I do? You see where I have the arrow pointed? What's the first thing I got to do to solve that equation?
Move the 5 to the other side.
Okay, let's do that step. That's bite 1. Now how do I get rid of the 1/4 power?
I have no idea.
Take it.
Multiply by 4?
Yeah, take each side to the 4th power. Now notice over here, when you multiply 4 times 1/4, you get x. So that's always the way to get rid of fractional exponents, is to multiply by its reciprocal. So that leaves x over here, and it leaves 625 over there. Okay? That's one answer. And it's not plus or minus 625. When I took x to the 1/4 and I took it to the 4th power, it became x, and 5 to the 4th power is positive 625. So now I'm going to do the same thing for this. X to the 1/4 minus 1 equals 0. Solve that. Same way.
So you add the 1 and then you multiply, or you exponent it to the 4th.
Correct. So what do you get?
4.
You get 1. 1 to any exponent is 1. Remember what exponents mean. 1 to the 4th means 1 times 1 times 1 times 1. Multiplying, not adding. 1 times 1. That's 1. Times another 1 is still 1. So there's your two answers. So the moral here is when you see things that don't look like obvious quadratics, if this power is this power squared, then you're looking at a quadratic. Before it was 4 and 2, right?
Yeah.
I don't mean squared, I mean multiplied by 2. If this exponent is twice this exponent, then you can solve it by factoring a quadratic. If I was going to use U-substitution here, I would let U equal always the middle term. It's always whatever that is what U is. And then U squared is x to the 1/2, and this whole thing becomes U minus 6U plus 5, which you can factor easily, and then you go back and do it the way I did the other one first, and you'll get the answer. It's actually a little faster to do it without the U-substitution, as you have figured out by now, I'm sure. When I didn't use the U-substitution, it didn't take it long. So it is a little helpful if you can figure out you don't need the U-substitution.
All right, so the next one is left parenthesis 2 plus radical negative 16, right paren, plus 3, or I get, sorry, plus left paren 3, plus radical negative 49, right paren.
Okay. Let's convert this to imaginary numbers. And then adding imaginary numbers are really easy. You just add the real part and you add the imaginary parts. So, what's the imaginary number that is equal to the root 16? Root negative 16, excuse me.
4.
4 what?
4i.
4i. It's got to have an I. Whenever you're taking the square root of a negative number, you're going to end up with an I. With me?
Mm-hmm.
Now do the same thing over here.
So it's 7, or 7i.
Yeah, again, let me review how we do that. Minus 49 is, take out the negative 1, leaving behind the positive number only. That's I. That's 7. So that's how you get that. Same way with root 16. Now that you have complex numbers, it's easy to add them. What do you get? Add the real.
5 plus 11i.
5 plus 11i, yeah. There's your answer. And you really have to do that before you, if I tried to add that to that, it'd be almost impossible unless I convert it to imaginary number first.
All right. So a rancher needs to enclose 2 adjacent corrals, one for cattle and one for sheep. If the river forms one side of the corral and 270 yards of fencing is available, find the largest total area that can be enclosed.
Is that an accurate picture with the squiggly line being the river?
Yeah, close enough.
Okay. Maximum area. Let's let this be x and this be y. So our maximum area function is going to be x times y, right?
Mm-hmm.
Wow. Again, you have not been taught the math to do this. This is a calculus problem. But we can do it still. I don't quite get that. But okay, so what's our fencing?
270 yards.
So 170 yards. What's that equal to in terms of x and y?
270.
270 yards.
Yeah.
In terms of x and y, what is that equal to? In other words, that's our perimeter, right? That's that, plus that, plus that, plus that, plus that. We don't need fencing on the river side. So we don't need this fencing down here. So let's write an equation that's equal to 270 in terms of x and y. What's this side? Here. In blue.
Y to the
No,
third.
what's this side right here?
Y.
Okay. What's that total side?
X.
Plus X. And I've got two more. I got one there and one there. What are those two?
Y.
So we actually have 3y plus x has to equal 270.
Mm-hmm.
Okay. I guess you do have the math to do this because it'll end up being a quadratic. So if I solve this, I get y equals minus 1/3 x plus 90. You see how I got that?
Mm-hmm.
Move the x over, divide both sides by 3. Now, the advantage of making y a function of x is I can go back into my area function, which is now completely, it started out as a function of x and y, but now it's only going to be a function of x. In other words, I've still got that x, but for the y, I now have this. With me?
Mm-hmm.
That's minus 1/3 x squared plus 9x. That is a parabola. And the height of that parabola is my area. In other words, if I were to graph that function, it's going to go down, right?
Mm-hmm.
So it must be a parabola that looks something like that. And there is a peak right there. At some value of x, the height, or excuse me, the area, this is a of x scale, is going to be at a maximum. And that maximum is going to occur at the vertex. Right?
Mm-hmm.
So, if we can figure out the x-coordinate of the vertex, we'll plug it in to this function down here and we'll get the maximum area. What is the x-coordinate of the vertex equal to? First half of the quadratic formula. One way to remember this is to think of the quadratic formula. One way to remember the quadratic formula is to know this.
It's b over 2a.
Minus b over 2a. Okay, in our problem, what is a and b? Notice we don't care about c. We only care about a and b. What's a?
A is y and b is x.
A is the coefficient of the x squared term. Whenever you have a quadratic and you're trying to figure out what a, b, and c are, they do not have an x with them. It's always the coefficients only. So a is negative 1/3. What's b?
90.
So what's negative b over 2a? What's negative b?
Negative 90.
What's 2a?
2 times negative 1/3.
So tell me what that is.
Two-thirds.
It's negative 2/3. Don't drop the negative signs. Okay, now those two negative signs cancel out, and I can get the answer by doing what?
Dividing.
It's a division problem right now. How do you do that division problem? How do you divide by a fraction?
Copy dot flip.
Do it.
So it's 270 over 3?
It's 270 over 2. That's why you should do this on paper. It's because it's really easy to make that kind of a mistake when you're doing it in your head. You do it on paper, you get 90 times 3 halves, which is 270 over 2, which is 135. So that is the x value where the maximum occurs. But they didn't ask for that, right? They asked for what was the maximum area?
What is the largest total area that can be enclosed?
That's asking for what the maximum area is. Well, remember this curve, this chart over here on the right, that is x versus area. It's not x versus y. It's x versus area. So I know that the maximum area is this point on the vertical axis. How do I get that point? Well, I know my area function. There it is. So what I want is what is a of 135? Boy, they ain't going to make it easy for you, are they?
Sure not.
So you need to figure out what a of 135 is, knowing that a of x is that. So it's minus 1/3 times 135 squared plus 90 times 135. The rest is arithmetic, but the rest is your answer. In other words, all of that is your answer. Square 135, multiply it by minus 1/3, and then add to that 90 times 135. Actually, we can almost do it a little easier. Here, let's do it a little easier. That's technically the correct way to do it. Let's go back up here to the graph of the corral. With me?
Mm-hmm.
We've proven that the length would be 135, that's x. And if I have 270 yards of fencing, that gives me 135 left to do 3 slots. 45 per slot. So each of these is 55, and the area of that is 45 times 135. A little bit easier math. In other words, the area is base times height. Base is 135, the height is 45. Easier than doing this on a calculator. You get the same answer, but 45 times 135 is 6,075. Now, the only reason you had enough math to do this problem is because it was all quadratics. So all you had to do is find out where the vertex of a quadratic was. You've been taught that. If this was a cubic, you would not have had enough math to solve it. That takes differential calculus. And it's one of the most valuable reasons for differential calculus is because you can maximize things. You can figure out what the dimensions have to be to maximize that area. It's not real clear when you get higher degree functions.
All right, so the next one here is answer in the form of a plus bi.
Okay.
So it's 8 plus I over -4 minus 2i.
All right. This looks like a division problem. It's not. What kind of problem is this? What do I have to do to the denominator?
Rationalize it.
Yeah, it's not called rationalizing, because rationalizing would be if it was an irrational denominator. But it's the same principle. Only instead of calling it rationalizing it, I call it realifying. Because what I'm doing is I'm taking an imaginary number and I'm turning it into a real number. How do I do that? What do I have to multiply it by to turn it into a real number? The bottom only.
Multiply by 2i.
No, you multiply it by its conjugate. Conjugate is always the same two terms with a different term in the middle. So the conjugate is that. That guarantees that we will not have an I in the denominator. You with me?
Mm-hmm.
Okay, since we can only multiply this fraction by the number 1, then I have to do the top also by the same thing. Now, let's do the bottom first. So you see. Now, whenever you multiply something by a conjugate, you really only need the left term and the right term. The two middle terms cancel out always. Notice the two middle terms are going to be plus 8i and minus 8i. So they're just going to go away. So the only ones you really have to worry about are that times that. What's that?
16.
And then minus that times that.
4i
4i squared.
squared.
Whenever you have one of these division problems, you're going to end up with an I squared. Because remember, we are converting the denominator to a real number. So if I got an I still in there, I don't have a real number. But if I have an I squared, I got a real number, because I squared is minus 1. So what's the total denominator now?
So it's 4. It's 16 minus 4 minus 1.
Give me a
minus
number.
3. 16 minus 3.
Okay, it's 16 minus 4 times minus 1, right? Do that.
Yeah.
Start from the inside always. Do that first. What do you get?
So it's 12.
It's 16 minus, when you do what I said to do, you get that. Minus 1 times 4 is a minus 4. So it's 16 minus a minus 4.
So it's 20.
Now we need the numerator. And to do the numerator, you just have to FOIL those top two terms and then simplify. So do it. FOIL it. It's 8 times minus 4.
-32.
Okay, give me each term of the FOIL. When I say FOIL, that's what I want, is every term. Give me the F, now give me the O, then give me the I, then give me the last.
Okay, so then the next term would be plus 16i.
Okay. Now the inside.
Minus 4i.
And then the last.
Plus 2i squared.
Okay. Now we have to simplify the numerator. We're going to be able to combine those two terms because they're both i's. And we're going to be able to combine that term and that term because they're both real numbers. So what's the real number part? Minus 32 plus 2i squared is what? Minus 32 plus 2 times minus 1. What's that?
It's negative 34.
Okay. And now combine the two inside terms, the 16i and the minus 4i.
It's 12i.
And then we all have that divided by our new denominator of 20. So what can I do now?
Take out a 2.
Okay, what do you get?
Or you,
But
so
you're
it's 12.
take out a 2, you're dividing the numerator by 2 and the denominator by 2. That's what you mean by take out a 2.
Yeah.
So it's minus 17 plus 6i, all divided by 10. Okay?
Mm-hmm.
So the problem is that's not in A plus BI format. We need it to be A plus B times I. We don't have it in that yet. How can I turn this into A plus BI format?
Multiply by 10?
No. We're separating it into two fractions. There's that fraction plus that fraction. So what are those two?
So it's negative 17 over 10 plus 6i over 10.
No, actually it's plus 3/5 I, because your 6/10 can be reduced further. It's 6/10 I. It's not 6i over 10. In other words, when you're looking at A plus BI format, A is a real number, B is a real number. In our case, B is 6/10, or simplified, 3/5. This over here is in A plus BI format. A is minus 17/10, B is 3/5. So this is what they're going to want. Notice it's not the same as that, not even similar to that, and not really all that similar to that either. In other words, you have to take it all the way down. You always have to split it into the two fractions when you have a number in the denominator like this. And the only thing you need to remember is that when you have a division problem with complex numbers, it is not a division problem. It is a realification problem. Your sole job is to make the denominator real. Math can handle a real denominator. Can't handle an imaginary denominator. There's no real meaning of dividing something up by some imaginary number of pieces. So you absolutely cannot have an imaginary number in the denominator. And that's the only tough problem there is with imaginary numbers. Adding them is easy, subtracting them is easy, multiplying them is easy. Only the division is hard. That's because it's not division, it's realification.
All right, so I got a couple of these are interesting here. So this one's another word problem.
Okay.
So C of X equals 2000 plus 70X.
Okay.
And then R of X equals 810X minus X squared.
Okay.
All right, so it says determine the maximum profit of the company. The profit of a company in dollars is the difference between the company's revenue and cost. The cost, C of X, and revenue, R of X, are functions for a particular company.
Okay.
And then, yeah, determine the maximum profit of the company.
So the profit of the company is cost minus revenue, right?
Mm-hmm.
There's cost. I'll put it in parentheses, even though they're not needed, but just to, they are going to be needed in the second part because I have a subtraction sign in there. So that's our profit function. Cost minus revenue. Now we just have to simplify it, and to maximize it, again, we're going to be looking for the vertex. And the vertex is going to tell us at what value of X will give us a maximum profit. And so first of all, let's simplify our profit function. Remove parentheses. I can remove those without doing anything. Can't remove the second ones without doing anything. So what's the final function here?
So 2000 plus 70X minus 810X plus X squared.
Okay. Let's simplify it. Let's move the X squared to the front. Let's see. 70X minus 810 is 740. Oops, and it's a minus sign. Plus 2000. So that is our profit function, which we want to maximize. There's only one problem with this. That goes up. That goes like that. Which means I've got the sign wrong on the X squared term. It's not cost minus revenue. It's revenue minus cost. Right? If you have a lemonade stand, it's your revenue you take in minus your costs. That's what your profit is. Right?
Mm-hmm.
So, profit function is revenue minus cost. So it's minus X squared plus 810X, that's the revenue, minus the cost, 2000, minus 70X. Now if I simplify that, I get minus X squared plus 740X minus 2000. That is my profit function. That makes a lot more sense because I want something that looks like this, where I have a maximum profit. That's the P of X scale, and this is X scale. So I need to find this value right here. And the only thing I can do immediately is find out the X coordinate of the vertex. What is that?
Oh man, I can't remember.
First half of the quadratic?
It's negative b over 2a.
Substitute it in. Let's see what that number is. It's minus b.
Minus b would be the 740, right?
No, b is 740. What's minus b?
Negative 740.
What's 2a?
Two times negative 1.
Which is negative 2. And that is 370. So if X represents the number of units manufactured, then we make a maximum profit when we manufacture 370 units. In other words, that 370 is there on the X-axis. So all we did was we figured out the X coordinate of the vertex. How do we get the Y coordinate of the vertex?
I'm not sure.
Quadratic. Well, we want to plug in the X value into that quadratic. And that'll tell us what our profit is. In other words, what is the profit when X is 370? Well, it's minus 370 squared plus 740 times 370 minus 2,000. You have a calculator?
Yeah.
Don't square minus 370. Square just 370 and then retain the minus sign. What's that?
136,900.
And then what's 370 times 740?
Uh, 273,800.
And then we still have minus 2,000. So it looks like, could they waste any more of your time making you do these ridiculous high number calculations? Go ahead and take 273,800 minus 136,900. What's that? 136.
Oh, that's 136,900.
Now, subtract 2,000 off of that. There's our profit.
134,900.
Yeah. Hold it. Did I do that right? Yeah, I subtracted 2,000. And that's the way you do all of those problems. In other words, the previous problem with the corral, same thing. We got a quadratic we had to solve. We had to figure out where the X produced the maximum area, and we had to figure out the vertex. That's why the vertex is so important in these parabolas. It's because it tells you where maximums are. And this might be a factory that has the ability to produce from 0 to 1,000 units a day. Okay?
Yeah.
So for them, it's extremely important to know exactly how many units to produce. And that number is 370. It's when they produce 370 units that they get a maximum profit. If they produce 369, it'll be less profit. If they produce 371, it'll be less profit. In other words, I've got to find the sweet spot, and the sweet spot is that vertex. Remember, this is not the y-axis. This is the profit axis.
All right, sweet.
Okay.
So then the next one is find the zeros of the function.
Okay.
So 3x squared minus 5x minus 13.
Okay. Again, I'm going to find the zeros this way. I'm going to let y equal 0. In other words, I'm going to find the x-intercepts. How do I do it?
So you do this is you do the two parentheses thing.
Well, we can try factoring it. It may factor, may not. If it doesn't factor, what am I going to do?
Try the quadratic formula.
Use the quadratic formula. The quadratic formula will always give you an answer. It's not just trying it. It will produce an answer for x. Okay? But it is worth one shot at factoring. I know the signs have to be opposite. And 13 only is 13, and 13 certainly isn't going to go on the right. It might go on the left. The 1 goes there. That gives you a middle of 10. That doesn't do it. If I put the 13 there and the plus 1 there, that gives you a middle of plus 10. So it does not factor. I just tried all combinations. So if it doesn't factor, I got to use the quadratic formula. Give me the formula first.
Negative b over 2a.
Actually, give me the entire numerator. That's not usually the way the quadratic formula is given. It's not really negative b over 2a. I mean, you could do it that way, but you only want a single denominator of 2a. What's the rest of the numerator?
Plus or minus square root of b. That's as far as I get.
Okay, what's a, b, and c?
A is 3, b is -5, and c is negative 13.
Okay, let's plug it in. It's negative b.
It's 5.
Plus and minus the square root of 25. That's always positive. Minus 4, and I always do it this way. I don't do any of this in my head ever. Now, do the inside of the radical first, always. And do it in two pieces. Always do this part first, so that you don't drop negative signs. Do that on your calculator.
It's negative 156.
Okay, so if I put negative 156 there, now what's 25 minus a negative 156?
131.
Nope. It's 25 minus a minus 156. Minus a minus means plus.
So that's 179.
181. Is it not? 25 plus 56 is 81. 25 plus 156.
Yep. It's 181.
Okay. Now, that is not divisible by 9 because the digits don't add up to be 9. It could be divisible by, I don't see any perfect square number that's going to go into that. Certainly not 4, not 9, not 16, not 25, not 36, 49, nope. And I don't need to worry about numbers above that. 64 certainly doesn't go into it. So that's a final answer. Was this just a solve? Oh, this was find the zeros.
Yeah.
So you got 1 0 at 5 plus root 181 over 6. You got another 0 at 5 minus root 181 over 6. And make sure you put this in right where you have parentheses because the whole thing is being divided by 6. the whole numerator. In fact, that's going to be tough to put in there. Here, let me help you. Parentheses, 5 plus 181 to the 1/2 power, all divided by 6. That's one answer. And then 5 minus 181 to the 1/2 power, 0.5 power, all divided by 6. So those are your two zeros.
All right, so this one, this is kind of, all right, so this one is just a true or false question, I guess. Okay. That's interesting. That's weird. All right, so the axis of symmetry of the function, so f of x is negative left paren x plus 6 right paren squared plus 7.
They want the axis of symmetry?
Yeah, so it says determine whether the statement is true or false. So the axis of symmetry for the function f of x minus that is x equals 7.
Okay.
So it's trying to determine on whether or not the axis of symmetry is x equals 7. I guess.
What's the parent function?
X squared.
Okay. Which I'm going to draw in one color. And then we're going to take each one separately, and I'm going to draw it in a different color. Start left to right. What's the negative sign do?
It's a reflection across the x-axis.
What's the 6 do?
Horizontal shift right 6.
Left 6. Remember, x minus h is the standard, and positive means to the right, negative means to the left. In this case, the h is a minus 6. Remember, everything's x minus h. Until you get to calculus where you see your first x plus h. Everything prior to that is minus. Therefore, if that's the standard, h is a negative 6. Negative means go to the left. I suppose you can look at it as positive means go to the left if you want to ignore that aspect of it. Just whenever you have a positive, it's to the left. Whenever you have a negative, it's to the right. Okay? What is the consequences of the plus 7?
It moves it up 7.
So there's my final function. There's the axis of symmetry. What is the equation of that pink dotted line?
That would be x equals negative 7.
That's the axis of symmetry. Whoops, not 7, 6. 6.
Oh, 6, yeah.
This is a minus 6. The horizontal shift was only 6 units. The vertical shift didn't affect the axis of symmetry. So going up 7 didn't matter. So the answer is false if they're saying x equals minus 7. X equal minus 6 is the axis of symmetry.
Okay. So this last one here is another kind of weird one. Let me see.
Okay. You want to try taking a picture of it and sending it to my phone just so we can see how long that takes and how quick it works?
No, it's just the way that they're worded is more interesting than anything.
Okay. So read it to me.
All right. Well, it's this here. We'll do this one first. So this one's 42 t squared plus t, and that whole thing is squared. So, yeah, there you go. So minus 44, and then left paren 42 t squared plus t, right paren plus 43.
What are we looking at here?
And that is all equal to 0. It just says solve.
What are we looking at? What's this called? It's quadratic.
Okay.
Now this one, I'm going to do it with the U-Substitution just because it's such a complicated U. Okay? And I always choose that one, the middle term. So U is equal to 42t squared plus t. Okay?
Okay.
So let's rewrite the whole thing as a quadratic in U. Easily factored. So U is equal to 43 or U is equal to 1. So now we go back to this equation up here on the right, U equals that, and we substitute the two results we got. 43 equals 42t squared plus t. We'll work with that one first. It's quadratic, so I want to move everything to one side, leave 0 on the other. .43 doesn't have any factors, so I know I got to have a 43 and a 1. And so I better break up my 42t squared as 1t and 42t. Now notice my middle term is going to be plus t. My end terms, I know they're correct because I broke up the 42t squared into t times 42t. Usually I tell you to use the factors that are closest together, so I would have started with 7 and 6. But because I could see that 43 was going to be one of my numbers, I know that that times 7 is never going to produce the middle term correctly. So I was able to gather that this had to be broken up as t times 42t. Okay? This gives you solution. T equal to 1 and t equal to minus 43/40 seconds. That's 2 solutions. How many should we have?
2.
In actuality, this is a quartic, right? I got a t squared being squared. So I know that if I were to carry out this process, I would have t to the 4th. So how many solutions should I be looking for?
All 4.
Okay, I'm going to get the other 2 by using that u. In other words, when I use substitution, I got 2 answers for u. Well, one of those answers produced 2 answers for t, as it should. Now we're going to get the other one. I'm going to substitute 1 for u over here in the lower left. Still 42t squared plus t. And we're going to solve that. So I'm going to bring the 1 over there, turn that to a 0, and I'm going to factor it. This time, it's going to factor into the 7 and 6. Signs have to be opposite. It's going to be plus and minus. No, it's going to be this way. And that way we have a plus 7t and a minus 6t, which produces my middle term properly. So, if I solve these, I get t equal to 1/7 for that one, and I get t equals minus 1/6 for that one. So there's your 4 answers to a quartic that was disguised as a quadratic. It's really the way to think about these. And they really went out of their way to disguise this one. Notice the most logical mistake people would make here would be to actually square that first term. And then you're going to end up with a giant quartic that you're going to have no idea what to do with. I wouldn't have any idea what to do with it. But because I can look at it and I can see that that term is the same as that term, and that's squared, and that's to the 1 power, so the exponent is twice that it's really a quadratic in disguise. And that makes the problem a whole lot easier to solve. It makes it solvable. If I were to expand this by squaring it, I'd end up with a quartic that I wouldn't have any idea how to solve. We good?
Yeah. I'm trying to make sure I got it all here. Yeah. So I guess this would be the last question, but I don't really know how to answer that.
Okay, we got one more. What's the last question?
So it's got a couple of parts to it. So it's the first question is find the vertex
of, is it a new function or is it the same function?
It's a new function.
Okay. Go ahead.
So it's x squared over 2 plus 4x plus 9.
Okay. We find the x coordinate. How?
Negative b over 2a.
Okay. What's negative b?
Negative 4.
What's 2a?
One.
Good. So the x-coordinate of the vertex is minus 4. How do we get the y-coordinate of the vertex?
Set it equal to 0?
No. Substitute your x-coordinate into the function. Right? Doesn't that make sense? If that's what y equals to, and we know x is minus 4 at the vertex, then we're just going to substitute minus 4 in there. And that's going to give us our y-coordinate. And then we'll have the x and the y-coordinate of the vertex. Keep going. Simplify this.
So 8/2 plus 9?
Hold on. Do that first. What's that?
16.
Okay, what's 16 over 2?
8.
Minus 16 plus 9. Now what's all of that?
1.
So what's our vertex?
Negative 4, comma 1.
You got it. So this minus b over 2a is really important. You had at least 4 problems today where you had to know that.
So the next part of this question asks for the axis of symmetry.
It's the x-coordinate.
So the parabola, wouldn't it just be the vertex?
No, it's the x-coordinate of the vertex. It's x equals minus 4. Remember, it's a vertical line. We have a parabola. It opens up. And it's the line that runs right through the vertex. So it's got to be an x equals something. And since the x-coordinate of that point is minus 4, then it's got to be x equal minus 4.
All right. So does it have a maximum or a minimum? So it has to have a minimum, right?
If it opens up, it's a minimum.
Okay.
What is
so then the minimum
1.
maximum value.
In other words, the minimum is going to be the y-coordinate of the vertex. But you got to be a little careful with the terminology here, because they can talk about the minimum occurring when x equals minus 4, but that minimum is still 1. So make sure when they're asking for minimums and maximums, are they asking for what the minimum and maximum is, or are they asking for where it occurs on the horizontal scale? They're two different things. One is the x-coordinate of the vertex, and the other is the y-coordinate of the vertex. In other words, this function can never get below 1. There are no values that ever produce a y less than 1. But it can be equal to 1.
All right. Well, that's the end of it.
Okay. What did you do on that test?
I missed 3 on this one, so I only got a 70 on this one.
Wow. 3.
Yeah.
I missed 3. How did I do that? Huh. Sorry.
Don't be sorry.
I thought I was doing all the math correctly.
Better than I would have done on my own. That's all I can tell you. Awesome. Well, yeah, thank you, David. I'll schedule something again this week. I do believe I have Tuesday off from work, so probably a Tuesday.
Yeah, I got nothing else going, so.
Awesome.
Pretty wide open.
Yeah. Sweet. Well, thank you, David. I'll talk to you on Tuesday.
Okay, sounds good.
Yeah, thank you.